Okay, so what we're going to do now is we're going to talk about the next chunk of material. These are an overview of Android components. And as you'll see, there's basically 4 main components and then sort of one cross-cutting component that we're going to be talking about. And we'll cover some of that today, and we'll cover some of that next Wednesday, and then I'll talk about what we're going to do on Monday later. Once again, there are lots and lots of pieces to Android. We're not going to try to cover every piece of every component. We're going to focus primarily on the parts that relate to concurrency and communication, but I will also spend some time on activities because that's what you're doing right now. An activity, as we'll soon see, represents a single screen with a user interface that does one focused user-facing operation. If you need to learn more about them, I recommend taking a look at the lectures from Professor Porter's MOOC, which are freely available. You can just subscribe. His class is still open. Great place to get an overview of activities that's probably complementary to what we're about to talk about, but goes into a bit more detail. Services, these are basically components that run in the background, and they perform longer running operations and/or they access remote resources where it may take some time to get to those resources. And we'll talk later about why that's important, this time dimension. There's a constraint on how long you can block when you're in an activity's main thread of control, or the user interface thread as it's called. So that's the second thing. We're not going to start talking about that probably till next week. The third component we're going to talk about are going to be, and we'll talk a lot more about services later in the course. The third component we're going to talk about are content providers, and they're basically an abstraction for being able to manage or mediate access to data that's shared often by more than one application. It doesn't have to be more than one application, but sometimes it's more than one application. So it's basically a way to store data persistently and to access it in a very stylized way. And we'll be talking a lot more about content providers later. They're really interesting, and they typically access something called an SQLite database, which is also very interesting. The final component, which we're not going to spend a lot of time on, but you need to be aware of its existence, is something called a broadcast receiver. And they're basically used to respond to, typically to system-wide broadcast messages or announcements that say something about the state of either the system, the Android infrastructure, or perhaps an application. And we'll talk more about those kinds of things later. There's one more thing we're going to talk about, and we're going to talk about it briefly right away because you can't get very far without talking about intents, which is the topic when you talk about activities. But later we'll come back and circle back around and talk a bit more about it. They're basically so-called passive data structures. It's just a bundle of data, plain old data, pods, that provide an abstract description of an action to perform. And you'll see that they're used in several different ways, which we'll talk about. They're used both to do implicit actions as well as explicit actions. And they're really the glue that holds a lot of Android's component framework together. This part we're going to cover first is activities and services. We'll probably get through most of the activity stuff today before the quiz, and then the next part will cover content providers, broadcast receivers, and intents. We'll also be using an example as sort of a running example throughout the slides, which is a download application, image download application. And there's a couple of different variants of it. You can see them here in the examples directory that's available at the GitHub repository. We'll be talking about this later, so if you look at it and it makes no sense at first, don't worry about it. We'll come back and discuss it in more detail. But basically what it allows you to do is it allows you to be able to type in a link that you want downloaded, and you can download it various ways, and when you click the button, it downloads a picture. So we'll play around with that, and you'll get a chance. You'll see lots of pictures. This was actually me when I was about your age back in 1982. Clearly, things change over time, right? Like hair length. Okay, so let's talk first about activities. So as we mentioned before, an activity represents a single screen that implements one user-facing operation. And here's a good place to learn more about activities. I'll give you these links. These are sort of the obvious links, right? If you Google activity Android, you'll find this one. But if you just want to click on it, if you have the slides open in PDF form, it'll take you right to the website. You can do lots of things with user-facing operations. You could show a login screen. You might want to read an email message. You might want to compose a text message or an email message. You might want to view or edit a contact and so on. Browse the internet. These are all the kinds of things that you can do with these user-facing operations that activities provide you. In our particular case, we're going to be downloading and displaying an image. So that's what this application does. And if you go look here, you'll see one way of doing that. And this is a way that uses activities and some cool concurrency stuff we'll talk about later. So those are examples of things that you can do with activities. Implementing an activity involves multiple steps. There are multiple things that you have to do. Anybody know, by the way, what these steps are? Very obscure movie reference. There's a very famous movie called The Battleship Potemkin, which deals with an uprising during the Russian Revolution. And it's famous in cinematographic history because there's a scene where these soldiers are walking down steps, shooting machine guns into a crowd, and there's like a baby carriage that goes bouncing down the steps. Those are the steps from the Potemkin movie. I just used that as a metaphor. It was a freely available image that indicated multiple steps, right? So that's the metaphor. So first thing you do is you're going to extend the activity class. So you can see activity as a class. Here's the class. We make a threaded downloads activity or whatever. You're going to make, in your case, you have a logging activity, or the logging activity that we have. You then go ahead and override selected lifecycle methods. So as we'll see, there's about half dozen or so methods that the Android activities framework uses to indicate to your application when state changes that the application or the activity may be interested in. And we'll talk about all these different methods. There's about a half dozen of them. You typically don't have to implement all of them for a given activity, but there's some things that are useful. You also have to implement other methods and or nested classes to actually provide the application logic or the business logic of your activity. For example, here, for the threaded downloads activity, we have a method called handle button click. So that's an example of a method that is connected to a layout via an XML file. And so when you click a button or you press a button on the screen, this method gets called back in your activity, and it does stuff. In your other application you're working on for the maps activity, there are similar kinds of things that you would do there as well. Typically, these other methods are where the other methods or classes are where the concurrency and communication take place. Some of that stuff sometimes goes in the so-called lifecycle methods, but more commonly they take place in the methods that you define that are part of the activity. What's the main difference between the lifecycle methods, these guys, and the business logic or application logic methods? What's the main difference between them? So the main difference is the Android infrastructure knows about these methods because that's part of the activity interface that it knows how to dispatch. And we'll talk about a pattern later that is implemented. If you use the layout XML file to connect the XML in an XML description to the buttons that correspond to the handlers, to the buttons that are clicked, then Android also knows about that as well, and it uses reflection in order to do that. But otherwise, these are just methods that you know about, but the infrastructure doesn't know about. You know about them, and then, of course, you call them, typically at the behest of something else that happens as a result of a callback. Yeah?
So is this kind of like overriding the paint in an applet?
Yes, this is exactly like taking an applet or almost any other kind of framework class and overriding selected methods. In fact, if we were really doing things right, and when you look at the code in GitHub, you'll see this, you typically put the @override method or @override annotation in front of all these methods. And that's an indication to the compiler that this is intending to override a base class method, and it'll check to make sure there is a method with that signature that you're in fact overriding to avoid confusion. Okay, and then finally, and we'll talk more about this later, and we'll go over this on Monday, you actually have to bundle up some metadata that describes how the Android runtime system is going to find your activity or whatever else you have and get it to actually do something sensible. So this goes into a file that's called the Android manifest XML file. And it's always at the top of every package. And when we dive into the package innards, you'll see how it works. And there's a bunch of stuff in there. And one of the things here is this is basically saying this activity is given this name, and here's where to go find it in the code, and so on and so forth. So there's a lot more here that we're not talking about yet. But this is how you connect the code you write with the code that Android knows about. It's a typical technique that's used these days in modern application frameworks and app servers and so on. Okay, so that's a really quick overview. Obviously, you're going to be implementing a map app activity, and it inherits from this logging activity that kind of helps the lifecycle logging activity. And so you have to fill in a few of the pieces, but that's basically how all user-facing operations are defined in Android. All right, next topic. Once we've defined this thing, how do we get the thing launched in the first place? How do we start up an activity? Now, there's a bunch of different ways that this happens. The typical way that it happens, the canonical way that it happens, is somebody creates something called an intent, and we'll talk more about an intent in a second, and they pass some information to the intent, and then they go ahead and they pass that intent to the start activity method. Now again, you'll see there's a whole bunch of different ways of doing this, and we're going to do a real simple one to start with at first. The real simple way to start is you actually hard code the name of the class file that you want to have started. That's the hard-coded way. So this would be an example of what's called an explicit intent. We're saying this intent is going to run this activity. Now, it's still fairly loosely coupled, but you're hard-coding to a particular thing, right? We'll see later that you can also have intents where you just do things like you're doing in your applications, where you're saying, here's an intent, and oh, by the way, here's a URL that I want it to work on, or URI. And then the magic of the intents framework, which runs under the hood here, will select the right application to use to launch, the right activity to launch. And that's done in a really cool way. We'll talk about that a bit more later. So the intent is this passive data structure. It's not really even much of an object. It's got a few object-like methods on it, but it's basically just storing data. And it describes the action that you want performed. So you typically will put, when you're doing things that aren't hard-coded like we're doing here, you'll say, this particular intent is going to be used when you want to browse something or when you want to edit something or so on and so forth. So those are the actions that you can define. So it's very verb-oriented. And so you create an intent, and then you can go ahead if you want, and you can put additional information into the intent. So these things are called extras. And that's basically kind of equivalent to passing parameters to a program when you start to run it. So if you've ever played around with command line arguments in C or C++, I think we might have touched on this very briefly in 251. When you run a program in C or C++ and you call it from the command line, or even when you call it from your IDE, if you give it arguments, it'll go ahead and pass those arguments to the program when it starts, and you get them through something called argv and argc. So the ways of being able to extract the arguments that are passed. With Android, what you do is you put extras into the intent, which are basically mappings of strings to some kind of data, string to string or string to int or string to bundle or whatnot. We'll talk more about that later. And then you can go ahead and put the extra with the intent. And then when the intent is passed to the activity, you can extract, you can get the extras from the intent that was passed along. So that's a way of passing information from one context to another. Why would you ever want to do this? What's the benefit of passing this kind of information?
You can have an unknown number of parameters.
Right, so your answer was a good one from an abstract point of view. You don't want to hard code yourself to one parameter, right? You have n parameters where you just put extras. The real question was, what would be some examples of things you might want to pass this way? What kind of information would you want to pass, whether you have one or many parameters? Robbie?
I mean, if the point of the next activity is something that's specifically dependent on what you're passing it, so like
a username,
right.
or some kind of code, or
you to log into it or something.
yeah, it could be a username. Probably wouldn't want to make it a password in plain text, but it could be a username of some kind, or some kind of identifier, or a string. Whatever you need to do, whatever you need to pass, you can pass those kinds of things. And then finally, you call start activity, and that, as we'll see later, will launch the activity via something called the Activity Manager, which is a system service that Android provides. And you can read more about it here. The Activity Manager is not very well documented, unfortunately, in the Android documentation, but I'll tell you a bit more about it. And the source code is available, and I've actually spent a lot of time looking at the source code for various reasons. It's really fascinating to look at in terms of all the different things it's doing. It basically is used to manage the life cycles of all the components in Android, except for content providers. So activities, services, and broadcast receivers are all handled through the Activity Manager. In fact, it probably should have been called Component Manager, not Activity Manager, because it seems more limited than it really is. Yes, sir?
Where is this start activity and like all these calls? Like, is this in a service?
Great question. These are being inherited. When you inherit from activity, you are getting start activity from that.
Where's the start activity print intent? Like, where is that actually called? That's not called in an activity.
Oh, yeah. Good question. So this would typically get called from a couple places. It could get called from the launcher, right? When you start out with your Android device, and it looks like, I think I have a picture of one here, right? When you're there and you go and you double click on the browser icon, the launcher application will go ahead and create the appropriate activity, or the appropriate intent, and then we'll go ahead and call start activity. That's one way to do it. Another way, what's another way that you do it? For those of you who've already done the programming assignment.
Call it from your activity.
Right, so in your activity, in your programming assignment, you have a method like handle click or something like that, or whatever, show map, which basically will call start activity. So you can call it in your program. So that's how you're going to do it in your application. All right. An application can define multiple activities. So one application can have many activities. For example, this application here, the way I defined it was I had this interface that looks like that, and then when you click on it, there's actually multiple different activities that do different things. So you can download images, you can display images, you can delete images, all these other kinds of good stuff. And for each of those different user-facing operations, I defined a separate activity. There are lots of different variations on this. I particularly like that style because it keeps each activity to do sort of one well-specified, localized thing. So that's one way to do it. If you take a look inside of Eclipse, you can actually get into a view where it'll show you all the activities that are part of your application that you're working on. So you can see we have multiple activities here, as well as other things like providers and services and so on. Now, activities, so an application can have multiple activities, and there's also another abstraction called a task, which is basically a chain of activities. So what the heck is a task, and what's a chain of activities? So to do something in Android may actually require multiple steps. So let's say that you want to send an email to somebody, right? So you're going to open up the email application, and then you're going to go ahead and you're going to want to choose who to send it to. So that may involve going to your contacts list and selecting somebody from your contacts list. And then after you do that, you're going to want to go ahead and send the message, and then you're going to send the message. And each of these different steps that you do may actually involve walking through different screens and different activities. And in fact, there's a whole concept in Android called the task stack or the back stack. And the activities that you may end up interacting with to carry out some task could in fact come from multiple applications. This is one of the really cool, powerful features of Android, is the fact that you can have user-facing experiences by users, that users experience, where each step along the way actually comes out of a different application altogether. But they can be glued together very flexibly by using intents and the ability to start activities via intents. That's why people often say intents are the glue that holds the activities together. So I'll show you an example here in a second. The activities that you have for a task are actually stored on something called a backstack. And so at any given point in time, there's one activity that's in the foreground. How can you tell which activity is the one in the foreground? It's the one you see, right? So it's the one that's visible at any given point in on your display. And as you're doing stuff, as you're moving through your activity task chain, then new activities will be pushed on the top of the stack, thereby occluding the ones that are being hidden because you have a new activity. And so you can push and pop things on the stack, and activities can be destroyed, and you can rearrange them, and so on and so forth. So to make this a little bit less abstract, here's an example. So here we have a Gmail, and I've got Gmail open up in my mail reader view, which is an activity. There's an activity for reading your mail, obviously. And now I want to go ahead and compose a new message. So I drew a little circle here just to point out where I was focusing on. So I would touch that with my finger, and that would go ahead and launch a new activity, which is the compose activity, right? It gives me my compose mechanism. And I could also then press on this, and it would pop up something to let me choose who I want to send it to, and that would be another activity. So there's activities that are sort of being nested here. We'll skip that. Let's say that when we're done composing the message, we want to send it. So we hit the send icon. That will go ahead and send the message, and then it'll return back to the previous activity. So it's popping off the back stack to go back to the previous activity. Now, that's not the only way to pop things off the stack. You can also, if I'm here and I decide, I don't really want to send the message after all, I can click the back button, and then that'll go ahead and pop me back to the previous activity, and it'll destroy the one that's on top. Yes, sir?
In the previous screen,
Yeah.
there was a keyboard. Are those is the keyboard an activity?
The keyboard is not an activity. It's more like a widget that comes up as part of the interaction with an activity. You can make that one of the things that comes up as part of an activity. Let's see. Here's a picture that kind of illustrates this, puts everything together, right? So we've got the launch screen. We launch the Gmail application. So the launch screen activity is occluded. We now have the Gmail application up and running. We click on that to compose a message. Those guys are pushed down the stack. The message composition activity is there. We then hit the back key. That activity is destroyed. And now we go back over here, and we're back to where we were before. And of course, if we hit the back button again or whatever, we'll go back, and that'll be destroyed, and this will be back. So it's pretty straightforward. I want to point something else out too. One reason I like Android, this is kind of a strange thing, I like Android better than iPhone, is because they have a consistent use of the back button, which drives me completely insane on the iPhone, because each application seems to do it a slightly different way. And sometimes you can't even figure out how it does it at all. It may seem like a minor point, but that has always bugged me. Yeah?
Well, I was just going to ask, I know originally we kind of defined an activity as having a user-facing operation. So is it, I guess, generally assumed that if nothing's changing on the screen, that it's still in the same activity? Like, if there's a refresh going on and new data is pulling in, is that in the same main activity?
Yeah. The display. A good example of what the question basically was, if something gets refreshed, like let's say you have your contacts list open, or you have you have your email open and a new email comes in, then how does that get refreshed? So there's various ways to do that. One way to do it would be to make you hit a refresh button periodically. Another way to do it would be to have the thing automatically refresh it. In either of those cases, that would still be the same activity. It would just perhaps be connected to a content provider whose content had changed, and you can have the activity be a so-called content observer, and the content observers are notified by the content providers when something changes. So there's all kinds of cool, sort of callback-like mechanisms using the observer pattern or the publisher-subscriber pattern in order to do that. So that wouldn't actually be a different activity. That would most likely just be something changing in the context of an existing activity. All right, any questions about that? So when you play around with your application, you will get a chance to experience this kind of stuff, because you'll notice when you start out, it prompts you for the location. You enter in the parameters. You hit show location. That starts up the maps activity, right, or the geo, either the maps activity or the browser activity. And when you're done, when you're tired of that, you hit the back button. That goes away, and it goes back to the show location, which you can then undo again and go back to the launch screen. Yes, sir.
This is kind of off topic, but you reminded me of a question I had about the assignment. You have it set up to where the default coordinates are showing grayed out.
Yeah.
It's empty.
Yep.
But in the example you had it where those coordinates were actually printed out, you want us to actually fill those boxes with default coordinates at the beginning of the app?
If you don't have to, the question basically is, do you want to have the default coordinates be filled in from the app? I just sort of put them into my strings file and just pull out the defaults and just display them as defaults, just so you'll sort of know what they are. But you could do several things. One thing you could do is, if someone doesn't enter any, you don't have to give defaults at all. And if they don't enter anything, you pop a toast up that says, hey, you forgot to enter in latitude or longitude. That's one thing you could do. I think the grad students have to provide defaults. And in that case, you could just make a const, a set of, final static longs that have the default coordinates, which are Vanderbilt's coordinates. And if they don't put anything in there, then you'll go ahead and use those. By the way, does anybody know how you find out if someone didn't enter any value in the edit text?
It's a null string.
It's a null string. It's the null string. The null string is not null. The null string, you basically will say something like, string param or whatever you call it equals. So that's how you check for the null string in Java. You check to see if it's the string that has nothing in it, as opposed to checking for the null keyword. So that's what you would do if you were doing the grad version, or either version. If you want to check whether someone entered any text, you would go and you would look at the results of the edit text. You would go ahead and get it out as a string and check to see what its contents were. Okay, so next topic we're going to talk about the lifecycle issues. These are really interesting, and that's why we have that logging lifecycle activity subclass or parent class of your map app activity. The way this works under the hood, I think I mentioned on the first day that there was a bunch of system services that Android provides. And one of those system services is something that's called the Activity Manager. And again, you can learn a little bit about it here. The better thing to do is go look at the source code. This is basically a system service that communicates state changes via the lifecycle methods of an activity. And if you go here to this link, it'll tell you in much more gory detail than I'm about to how all this stuff works. I'm going to give you the Cliff Notes version so you'll know what's going on. There's lots and lots and lots of details, most of which you don't have to know or care about at the moment, but it's important to know where to go find about them. So this is a state diagram, or state chart that basically comes from the Android documentation. And it walks through the various states that are dispatched, that correspond to dispatches by the activity framework, which is implemented by the Activity Manager service, largely, in order to dispatch callbacks to your activity to do stuff. Now, keep in mind that whenever those callbacks take place, you also need to call up to the parent's callback hook as well. This is what basically is called the decorator pattern. We talked about it briefly in 251. If you don't do that, then certain things won't get propagated up the chain. So the first method that you'll encounter, and this is one of the ones you have to implement, I think it's actually largely implemented for you with a couple lines left out, is called onCreate. And this is called by the activity framework, by Android's runtime system, to initialize an activity when it's first created. And this is basically sort of a creational pattern, sort of a virtual constructor. So it's separating out the creation of the object, which was done by the Android infrastructure, from the initialization of the object. It's giving you a chance to initialize this object. And what you're going to do, of course, typically is set the main layout, and which gives the window, look and feel. And then in our case, we're also going to cache a couple of things like the edit text and the text view and so on. So that's what onCreate does. Next thing is called onStart. This is called when an activity is becoming visible to the user but has not yet become visible. And there's certain kinds of initialization hooks that need to be done in the onStart method. When we get a little further down the road and we start talking about some of the stuff relating to bound services, for example, you'll see that the onStart method is typically where you connect to a bound service. There's also something called Onresume, and that's called when the activity is just about to start interacting with the user. And after Onresume returns, then what happens is basically the activity is in the running state, and any input you type in goes to that activity. So before this thing gets called, that's not the case. After Onresume returns, then anything that happens will be happening in the running activity. So now at this point, your activity is up and running and it's doing stuff. However, you have to be prepared for your activity to stop doing stuff. Why would that occur? Well, one thing might happen would be that perhaps a dialog pops up, like a dialog box. When a dialog box pops up, something interesting happens. A method called Onpause, which is paired with Onresume, is called. And that's called when you're leaving an activity, but the activity is still visible in the background. So the activity hasn't disappeared. It's just not currently got the focus. Right? So when a dialog pops up, the activity that's behind it is still visible, although partially blocked, and the focus is now on the dialog, right? Maybe it's asking you, is it okay to terminate this application, yes or no? So if you click yes, it goes to the dialog, not to your activity that's occluded or partially blocked. So that's what Onpause gets called. If the activity is actually going away, or not going away, becoming invisible, like in your map app demo where you click show location and the map pops up, then the map app demo application will no longer be visible, right? It'll be hidden by the activity that just replaced it as the visible activity. And then Onstop will be called. And there's certain things, certain resources you want to release when Onstop is called. And we'll talk more about examples of those things later. Now, keep in mind, when your Onstop method is called, that doesn't mean your activity has disappeared. All it means is that you're no longer visible. And so you should free up resources that might be usable by other things when you don't have to display anything. When your Onstop method is called, probably somebody else's activities Onresume method has just been called, or Onstart method has been called, right? So they're becoming the focus of the attention. If you play around with an Android phone for any length of time, these things become quite clear. And if you look at the logging output in the logcat that we have instrumented through those logging lifecycle activity methods, you'll also see what's going on. OnRestart is called when an activity comes back to the foreground after being stopped. And the main distinction here is to distinguish between when you're restarted from when you were first created. So OnRestart is a hook method, not actually used very frequently, by the way. OnRestart is always followed by a call to OnStart, but it's a way of doing something, perhaps, if it's important to distinguish between restarting versus the first time in. OnDestroy is called when the activity is going away, like you finished it, or the system decides it's done, and so on and so forth. And in the OnDestroy method, that's the time to release the resources, to free things up. Now, keep in mind the following. This is very important, and it's very confusing at first, and it seems sort of bizarre. Onstop and OnDestroy may not actually be called because the low memory killer may target your activity's process for termination and just shut it down. So Onpause should get called, but Onstop and OnDestroy are not guaranteed to get called, which means if there's really important things that you need to make sure get done when your activity is going away, do them in Onpause. You can't count on Onstop and Onresume being called. It's kind of squirrely. This happens a lot less nowadays because there's a lot more memory, but back in the early days, this was happening all the time. Robbie?
Is there any other way to detect if you're being killed in a low memory situation?
Not easily, no. There is a way to distinguish why you're being destroyed. You can either be destroyed because you decided to shut yourself down voluntarily, or because the system decided to shut you down. If you decide to shut yourself down, then the isFinishing method will be true if you call that. Okay, the key thing, kind of connecting this back to CS251, the way all this stuff is working under the hood is actually the template method pattern. So if you remember the template method pattern from 251, basically, without getting into too much gory detail, under the hood there is something called an activity thread, and it's got a bunch of methods that are managed by the Android infrastructure. And the activity class has a method called performStart, which is a template method. And the performStart method, if we look down here, you can see that it basically goes ahead and does some stuff, and then it calls call activity on start. And that method turns around and actually calls the template, this calls the hook method, or the so-called primitive method in the template method nomenclature. And that's where you put your behavior that you want to override. So that means that there's certain things that always get done, certain initialization and context setting behavior that's done by the template method, and then it calls out to your hook method or your primitive operation. And that happens for on start, on stop, on pause, on resume. If you ferret around through Android long enough, you'll see how all these things happen under the hood. And all the source code is available here. We'll take a look at this source code later. It's really cool. You can kind of see how it all works. So some stuff like the activity thread is actually in this app directory, but it's not in activity. It's an activity thread. So the point of that is that all the patterns we did in 251 still apply. Okay, fourth and final overview of Android activities. So there's certain design constraints that restrict the way in which you can interact with activities. Very stylized things. Now, this is what I'm about to talk about is both centric to Android. They're Android-specific things, but this is not uncommon. Almost every environment that does user interfaces behaves something along these ways. Android applications have one and only one user interface thread. And the user interface thread is the place, not surprisingly, where all interactions with the user takes place, whether prompting the user or displaying stuff to the user and so on and so forth. And that's the only place that can do things that interact with I/O to the user. And if you take a look at this link, it explains all this stuff. All the components in the same process use the same user interface thread. So all these Android components. So activities, services by default, content providers by default, broadcast receivers by default all use the user interface thread. And this thread is used to receive system notifications and broadcasts. If you're a broadcast receiver, it interacts with the users. It performs all those lifecycle operations we just looked at. So Onstart, Onstop, Onpause, Onresume, those are all callbacks done in the context of the user interface thread. Moreover, because of the fact that this is the way things work, the user interface components or toolkit components, things like menus or views, menus, all the stuff that goes into interacting with the user, those things all have to be done in a way that's not called from multiple threads. They are not thread safe. There are no synchronization mechanisms on those widgets. They're just accessed, and they assume that they're being called in one thread, and that thread is the UI thread. Now, anybody know why that is? Why do they do that? What's the motivation for this? What's the motivation for making all user interface operations have to run in one thread, which is the main thread? Yeah?
Multi-threading is really hard.
Multi-threading is really hard. That's very good. So multi-threading is really hard, and we don't want to have every application developer have to understand multi-threading, number one. And number two, making components that are multi-thread safe requires explicit locks, and explicit locks are expensive, relatively speaking. And therefore, we don't want to have to do them if we don't need to. So the two main reasons for not having the UI widget, toolkit widgets, multi-thread aware is it would make it harder on the developers of applications, and it would be less efficient. So those are that's the world you live in. And almost everybody who works in a user interface environment has these kinds of constraints. So the UI thread cannot be used to handle, so there's some consequences of this. And here's more description about UI thread and how it works and why it needs to be accessing things in a non-thread safe way. One of the consequences of this is that operations that run in the user interface thread must be short duration. In fact, if they block for any more than 3 to 5 seconds, you will get the dreaded application not responding or ANR dialog. And you'll get a chance to kill your application. And that's because the system's assuming something's gone wrong. If your main thread is blocked for any length of time, it's probably either a bug or user error or something like that. It's probably a bug. The program is probably written incorrectly. So you'll get this way of terminating the program in that case. So you can go here and learn more about that. Consequently, long-running operations, long-duration operations, have to run in background threads. So they're going to run in a background thread. Now, it turns out that we'll see that the canonical way of doing this in activities is either to use the Hammer framework, which is handlers, runnables, and messages. That's the one up here. And that's the one where you have to know how to use runnables, messages, threads, handlers, and that kind of good stuff. Or you use async task. The async task framework has very similar semantics to the Hammer framework, but it's more sophisticated. The framework does more for you. So you can use the async task framework without knowing about handlers, threads, messages, or runnables explicitly. That's all hidden from you, from the cool way that it works. And we'll talk lots and lots more about that stuff. Now, these background threads, so far, since this is a discussion of activities, I've primarily focused on activities. And so activities can be multi-threaded. All this point is just leading up to the fact that activities can have one or more threads running in them. And long-running stuff needs to run in background threads, and they need to be able to communicate back to the user interface thread when they want something to actually be displayed to the user. And we'll see that this implements a bunch of cool patterns that we'll talk about later. You can also run background threads in services. And that's what we're going to start talking about next Wednesday, and I'll explain why in a second. But that's another way to do long-running operations, is to run them in services that run in background threads. One way to do them is in activities, one way to do them in services. We'll talk later about why you would choose one approach versus another. Okay, are there any questions about anything that we just discussed? Yeah?
Yeah, so are activity and services completely separate processes?
Great question.
Activity, like, is the UI thread always in the activity?
So the UI thread is always, activities are always handled in the context of the UI thread, things like lifecycle methods and button presses and other stuff. Now, keep in mind, you can spawn threads that interact with the UI thread using the Hammer framework and async task, but by default, if you don't do anything else, activities are in the main thread. Ironically, if you don't do anything else, services also run in the main thread, which is kind of weird. But that's not very typical. You typically will do one of two things, and we'll talk more about this later. You either spawn a thread or use a service called the intent service that can create a thread that runs in the background. That's one way to do it. Or you can have a special little tag in your Android manifest file in XML format. It's an attribute that says, run this service in a separate process. So we'll see later that you can either programmatically have services run in the background by programming them to do so, or you can configure them to run in the background process via metadata put in the Android manifest file. But we'll cover that later. We don't have to worry about that right now. Let's see. I'm trying to think. I was going to say a few more things about activities. At any rate, at this point, you should have enough information to understand the gist of the program at a high level. What you need to do now, of course, for your assignment is to make it work the rest of the way.